Hello and welcome to a test review for my Precalculus class Math UC series, and it's going to be a fun time. So let's just dive right in here. We've got find the value of the trig function indicated, and in this section we have one of each trig function intentionally: sine, cosine, tangent, secant, cosecant, and cotangent. So maybe cotangent isn't what we want to start with. Maybe we'd rather start with sine, cosine, and tangent and work our way through. So we are doing this for theta, which is a marked angle in each of these triangles. We need to basically have the understanding of which sides go with each trig function, and we also need to have the idea of which ones are reciprocal. So the reciprocal of sine is cosecant, the reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. So sine of theta here is opposite over hypotenuse, so 3 over 5. We are going to leave it as 3 over 5. We're not going to put a decimal. We're not going to actually try to find the angle. That's just our answer, 3 over 5. Let's do cosine. So adjacent over hypotenuse is cosine. So the adjacent side would be 15. The hypotenuse would be 17. So cosine is 15 over 17. Also doesn't simplify. So that's our answer. Tangent, so number 6 here, is opposite over adjacent. So that would be 6 over 8, which does simplify by 2. So that'd be 3 over 4. We do want to simplify if we can, and rationalize if we need to, but not change to decimals. Then secant, cosecant, and cotangent. So cosecant is the reciprocal of sine. So if I find sine, or at least think about what sine is, that it's opposite over hypotenuse, for cosecant we need hypotenuse on top and opposite on bottom. So that's every time I do it, that's the thought process I go through. And it's been years that I've been doing this, so don't know if that's a good thing or a bad thing. So 7 square root of 10 is the hypotenuse. It's going to be over this opposite side, which is 7. 7 square roots of 10 over 7. The 7's cancel, leaving us with just square root of 10. So that would be our answer. Secant. Well, this looks like a special right triangle. Secant is hypotenuse over adjacent because it's the reciprocal of cosine. So 6 square roots of 2 over 6. Which, again, we've got some canceling there with the 6's, so it should just be square root of 2. And then cotangent is the reciprocal of tangent, adjacent over opposite. So adjacent is 12, opposite is 16, so 12 over 16, which simplifies by 4 to be 3/4. So, pretty simple stuff, hopefully there. You do have to do a little bit of memorizing to make sure you understand how that works, but not too bad. Let's look here at 7 and 8. Say find the measure of each angle indicated, round to the nearest tenth. And we are going to find these in degrees because that's all we know how to do at this point in what we're doing. We look at the sides they give us. We could find the third side using the Pythagorean Theorem, but you could mess that up. So I would say just use the sides they give us. This is the opposite side. This is the adjacent side. So that means we need to use tangent. Tangent of theta is 9 over 15. The way we find the angle is on our calculator. We do inverse tangent of 9 over 15, or the book likes to call it arctan, and that's the same thing. But on your calculator, it looks like tan negative 1. And so I'm going to bring my calculator over here and find inverse tangent, and then do 9 divided by 15, and it says round to the nearest tenth, so that's 31.0. So rather large 0 I put there, but I'm sure it's fine. 31.0 is the answer to that. On 8 here, we've got an adjacent side that we know, and we've got a hypotenuse, so that's cosine. If you're thinking, well, couldn't we use secant? Technically, yes, but if you're assuming you're using a TI calculator, they don't have a button for secant, so you might as well just use inverse cosine instead. So cosine of theta is 9.4 over 11, so we're going to do inverse cosine of 9.4 over 11 on our calculator. And wow, these were really close. That would be 31.3. I'm talking to the video camera. I'm making myself a video while I'm making other people a video. Okay, so 9 and 10 is similar, but this time we know the angle and we're looking for a side, so we're going to have to solve an equation to figure this out. So for 55 degrees, this would be opposite and x would be adjacent. So we're going to say that that means tangent of 55 degrees equals, make sure you put the opposite side on top, so that's 11. Adjacent is on bottom. To work this out, we need to times both sides by x, and then we divide by tan 55. And so in my calculator, I'm going to do 11 divided by tangent of 55 degrees. And you do need to do it in that order, by the way. In case you're wondering here, I'm using Desmos as my calculator of choice. So, and if you do use Desmos, it's a great tool. I have already changed it to be in degree mode here using this little tool icon. So keep that in mind. It does need to be in degree mode. This said round to the nearest tenth, so that's 7.7 for our answer. This one is adjacent to 34 and 7 is the hypotenuse, so we're going to use cosine. Cosine of 34 degrees equals x over 7. When x is on top like this, it's easier when we're solving because all we need to do is think, well, let's times by 7 on both sides. And our answer is whatever 7 times cosine 34 is. We don't have to do like the extra step that we had on the other one. I definitely like it better whenever x is on top. So this is 5.8. Okay, 11 and 12 say solve each triangle, and so the difference here is that now so the difference when we're solving the triangle is that they want us to find all of the missing pieces. So we need to know all of the angles of the triangle and all of the sides. They have to basically give us 2 of the angles because we need to know it's a right triangle, and they need to give us 1 of the sides, and then we can figure it out from there. So the easiest part is finding the missing angle. Since this one on angle A is 33 and C is a right angle, we need to just figure out 33 plus what gives us 90, because that's what's left for angle B. So you can do that in your head or you can do that in your calculator. 90 minus 33 is 57. So angle B is 57. It may be a while since you've done this, written an angle symbol like that, and we actually probably should put an M if we're really trying to be geometrically correct here. The measure of angle B is 57. Then we need to find this side. So what we'll do with sides on labeling them a lot of times is we'll name them the lowercase version of the angle they're across from. So this would be a lowercase c, this would be a lowercase b, and this would be lowercase a. So that would kind of help us to have names for these as we set up the rest of this. Let's use 33 just in case we got 57 wrong. Let's use 33. That means this is the opposite side and the hypotenuse, and opposite side and adjacent. So two different trig functions. So opposite side and the adjacent side would be tangent of 33 equals 10 over b. So we're going to times both sides by b and then divide by tan 33. So in our calculator we need to do 10 divided by tangent 33. Which is 15.4. So B is 15.4. For C, we would do not tangent. I'm still going to use 10 because I know that 10 is right because they gave me 10. So that's opposite and hypotenuse, which is sine. Sine of 33 degrees equals 10 over c. So same process basically, just with a different trig function. I need to actually find it. I don't need to write it down. 10 divided by sine 33. Let's see. Whoa, that's not what I wanted. $18.4. And we're going to do the same thing for 12. This is, I imagine, one of the places where you might have difficulty on this review. Not the only place, maybe. But it's one of the places just because it asks us to do more stuff. So if you found that helpful, like you didn't know how to do 11 and 12, and now you've done 11 with me, you might think about pausing the video and trying 12 on your own now, and then start it back up when you're ready. I'll wait. Just kidding, because you paused it, so I don't actually have to wait. Okay, so I'm going to label these sides. This would be B, this would be C, this would be A. So angle B up here is what we get when we do 90 minus 62, so we need 28 for that. And then we're going to use our trig functions here. If I want to find B, that would be tangent of 62 degrees equals opposite over adjacent, so 3 over b. If you've done enough of these, then you may have the pattern down here so that as soon as you see b's on the bottom, you know, oh, I'm going to do 3 divided by tangent of 62. That's great. I'm a fan of noticing patterns and being able to do less work because of that. But you do want to make sure that you actually have it down well enough to do that. No thanks. 1.6. So side B is 1.6. And then I need side C, which is the hypotenuse. So I'm going to use opposite and hypotenuse, which is sine. Sine of 62 degrees equals 3 over c. So I'm going to do 3 divided by sine of 62 because I have to times by c and then divide by the trig function. Whoa, not again. Let's see, 3.4. You can do a little bit of checking here. The figures may not be drawn exactly, but they're going to be pretty close, I would say. And there's things like, the hypotenuse is supposed to be the longest side because it's across from the largest angle. So if we hadn't gotten something bigger than 3 for C, that'd be a bad sign. So you can do some things like that to try to help you double check that what you have makes sense. Now we're talking about angles. The rest of this is angles just that are in kind of the coordinate plane. So remember when we draw an angle, the positive x-axis is 0 degrees, and then each quadrant basically makes up 90. Positive is counterclockwise, and negative angles go clockwise. So negative 170, this would be negative 90. So then we need to go almost all the way to the next line, because this is negative 180, but not quite. So this right here would be negative 170. It doesn't have to be super exact necessarily, but in the right quadrant, it'd be even nicer if it was, closer to the correct quadrant line. Like drawing negative 170 over here is not really as correct, right? Because it's not supposed to be close to this. That'd mean it was close to negative 90. It needs to be closer to negative 180. But typically we're not being asked to like use a protractor to be super precise here. All right, 130. We'd have to go positive 90, and then how much past positive 90 is 130? It's 40. So it's kind of in the middle-ish. So here's 130 degrees. That is all it asked us to do there. So we drew the angle in standard position. We're good. Now this next thing says find the reference angle. It doesn't give us a XY axis, but that to me seems like the best idea because I personally like visualizing this. If I go negative 280, I need to go this way. That's negative 90, negative 180, negative 270. I need to go a little bit past negative 270 and make my angle here. Because I went 10 past, that's going to help me find the reference angle. Remember, the reference angle is this angle inside the triangle that we get when we draw up or down to the x-axis. So that has, since we were 10 on that side and it has to add up to be 90, that would be 80 degrees for this reference angle. There's probably other ways you can come up with that answer, but that's my process that I go through. 445, well, that's bigger than a circle. If we go all the way around the circle, we're at 360. So how much farther past are we going to need to go? Let's subtract 360. So that'd be 5, 8, 85. So we go all the way around the circle and then we go 85 more. So almost up to 90, but not quite. So we're actually in the first quadrant again. Beautiful looking triangle here. So since we were 5 short, then our reference angle inside of our triangle is going to be 85 degrees. Okay, we're going to do find the exact value for the trigonometric function, which, just to clarify that, exact value refers to having radicals and fractions, not decimals. Technically, if you got like a half and you wrote 0.5, technically that is still an exact value. But what would not be an exact value would be putting 0.3 when your answer was 1/3, because 0.3 is rounded. 1/3 is 0.3 repeating. The same would be true if you got an answer with a square root at the end. Square root of 2 is 1.4 and continues on forever. So if you round it, you are not giving the exact value. So that's my soapbox there. Let's figure out what this is. So because all they gave us is the angle, this has to end up being a special right triangle. So we think, okay, this is 180. And I feel like I picked poor examples here in a way, because these are going to be similar triangles. I should have picked so that we'd have a little bit of a difference here. We've got, this is 180 degrees, so 240 is 60 past that. And so we basically need to know what a 30, 60, 90 triangle is, what the sides are. This would be square root of 3, this would be 1, this would be 2. And both of these are negative because left is negative and down is negative. So cosecant is hypotenuse over opposite because it's related to sine. So the hypotenuse is 2. The opposite side is negative square root of 3. Let's rationalize that by timesing the top and bottom by the square root of 3. So we get negative 2 square roots of 3 over 3 for our answer. So not whatever that is as a decimal. We get negative 2 square roots of 3 over 3. Let's do cosine over here. So make our triangle. Think about, okay, if this is 300 to get around here, that means this is 60. Like I said, I should have picked a different angle to use here so that they wouldn't be the exact same triangle. 1 is positive, negative, or square root of 3 is negative, and cosine is adjacent over hypotenuse, so that's 1/2 for our answer. Oh good, there's more of them. Good. So that means that for this negative 315, the angle right here is a 45-degree angle. So that is the other kind of right triangle. Special right triangle is a 45, 45, 90. 1, square root of 2. Okay, so sine theta here of 45 is opposite over hypotenuse, which is 1 over the square root of 2, which will rationalize and get square root of 2 over 2. This one is a 30, 60, 90 triangle, but the perspective is different than in 17 and 18 because this is 30 left over here. So this side will be 1, although it will be negative. This side will be negative square root of 3. This side will be 2. So cotangent is adjacent over opposite, so negative square root of 3 over negative 1, which the negatives cancel, and it's just square root of 3. Okay, so on these are not special right triangles. We're using this point that we've got. Okay, so we draw this triangle. The negative 4 is telling us x, because it's telling us how much we're going left, and then the negative 3 is telling us how much we're going down. We can find the third side if we need to, which we do because cosine is hypotenuse, or has hypotenuse. So we do the Pythagorean Theorem, or if you realize this is not a special right triangle, but it is a special triangle in that it's a 3, 4, 5. There are very few sets of 3 numbers that fit a squared plus b squared equals c squared and are all whole numbers. So 3, 4, 5 is one of them. But if you didn't know that, you could do the Pythagorean Theorem like so, and you should still end up with 5. Cosine is adjacent over hypotenuse, which is negative 4 over 5. This didn't tell us to find the exact value versus a decimal, but I'll try to add that before the test, because I do want the exact value and not just whatever decimal you might get on your calculator. This one over here, tangent, and we've got 11 and 2. This side would be 11, this side would be 2. And since it's tangent, we don't even need the hypotenuse. You can find it if you want to, but if you realize you don't need it, you'll save yourself some time. This should be 2 over 11 for our answer. (23) Sine. So negative 6 is telling us our x, square root of 13 is telling us our y. Sine is opposite over hypotenuse, so we do need to figure out the hypotenuse here. We're going to do the Pythagorean Theorem. So this is 36 plus 13, which is 49. So that means that C is 7. So our hypotenuse is 7. We're going to do opposite over hypotenuse, so that's square root of 13 over 7. Cosecant. We will need hypotenuse for. This is secretly a special right triangle, and I know that because both sides are 13. It doesn't really matter, but I guess it would help me maybe find the third side. Like because these two sides are the same, I know that the third side, the hypotenuse, has to be this number with a square root of 2 next to it. And if you use the Pythagorean Theorem, you'll get that as well. 13 squared plus negative 13 squared. It might not be as obvious. You'd get whatever 169 times 2 is. It would be 338. And when you simplify that, you go back to the fact that it's 2 times 169. So it's 13 square roots of 2. Cosecant is hypotenuse over opposite. So that's 13 square roots of 2 divided by negative 13. The 13s cancel. So we just have negative square root of 2. Final page. Draw a picture of an angle of elevation. I'm not looking for something super fancy necessarily, but an angle of elevation starts from the perspective of the person and goes up. So here is an angle of elevation. Our person would be down here looking up. Don't really like that there's a stick going out of their head, so I'll take that off. Okay. Whereas an angle of depression would be when a person or whoever is looking is in the air. They've looked straight out, but then they've looked down. This is our angle of depression. So, instead of making a really long word problem, or not really long, but just instead of making a word problem and expecting you to figure it out and draw it by yourself, I thought, okay, well, let's just make sure that we understand the idea of elevation and depression. And then here I do have a word problem for you, but I've given you a picture to use to hopefully help. It does still use the words angle of elevation, but I'm hoping that it's pretty straightforward since I gave you the picture. Dan, look at Dan here. Dan looks kind of like Humpty Dumpty. Dan is standing between two buildings. The angle of elevation to the first building is 32 degrees. The second is 47. It doesn't actually matter which one of these you label which, as long as you are consistent, but because I did actually try to make them kind of to scale, it makes more sense to put 32 on the left and 47 on the right. So by consistent, I mean whichever angle you put for the first building, wherever you put that, we need to put the 1.5 as well. So this length is 1.5. And then this length is 2.3. I made up these numbers, so I don't know how good of an actual, like, real life situation this is. Probably not very good at all. So we are asked to find out how tall each building is. It doesn't matter what letter we use to represent their height, but we have two things basically we're solving for. We're finding the opposite side, and we know the adjacent side. So tangent of 32 degrees equals x over 1.5. That's going to get us the height of the first building. And then tangent of 47 degrees equals y over 2.3. That's going to give us the height of the second one. Each of these we just need to multiply by what's on bottom to solve. So the first building is, let's pull out our handy dandy calculator, and 1.5 tangent 32 is 0.9. I think I'm going to round to two decimal places, 0.94. 0.94 kilometers. And so if we actually think about how long 1.5 is and how this side is shorter, that makes sense that we're getting something less than 1. The first building is 0.94 kilometers tall, and the second building is we're going to do 2.3 and 47. .47 kilometers tall. And there we have it. If you are not already subscribed, please subscribe, like, comment, all that jazz. And good luck as always with everything that you are doing with math.